Hello everyone at the Big Bang Competition 2021. I'm Harry Lunt and this is my robot BluBot entering from Walton High School. So the idea of this robot is that it's an automatic gardening robot. So it's got a pump with a pipe connected, which is just here, and it's got a soil sensor which work together by the robot moving around the garden to detect the soil at various places, how much moisture is in it, and then pump the amount of water accordingly. So I'm going to quickly run through the potential uses of this, and then I'm going to show you the components that go into building it, and then I'm going to show you a little test out in the garden, and then I'm going to show you the CAD and software that went into designing it. So this could be really useful for people who've gone on, say, holiday, or people who necessarily can't get into the garden particularly easily, or don't have time to do much gardening, because it maintains the plants during particularly dry seasons by watering them appropriately. And if you've got any particularly dependent plants that require specific amounts of water, this is really good because it can detect the species, which using, for example, like QR codes, which I'm going to look into as sort of a progression of the design. Using a little camera to detect the QR codes, it will identify the species and water it, it'll adjust the moisture sensor to give it the correct amount of soil depending on what it reads. It's really useful because, you can just leave it outside. It requires hardly any maintenance. It powers itself off the solar panel. So it's clean power supply. It's not going to cost you anything to run, except, it'll fill up off rainwater. That's why the panel's at a slight angle, because the water just drains down into the tank at the back. I haven't put the pipe in yet, but that's what it'll do. And then it'll just reuse rainwater, and it's stored in a little watertight tank so it can't evaporate particularly easily. So I'm going to leave it at that for the basic concept, and I'm going to show you all the components now. So I'm going to very rapidly just run through all the components. So we've got the soil sensor at the front connected to a servo motor, and there's two 12-volt motors that power the tracks. We've got anything in blue's 3D printed on the 3D printer, or this little brown piece at the front. Got a little breakout board here from the 5-volt supply from the power bank, which can be charged via the charge controller. That powers the Raspberry Pi central computer and the HDMI screen at the front. And we've got the little battery pack here. There's 12-volt that powers the two motors. The solar panel on top connects in this sliding connector that I'll show you in the CAD section of the video. And we've got the water tank at the back with a positive and negative connector that pumps water out the front. This is an Arduino Nano and a H-bridge controller. So this connects to the pump just here, the water pump, and the Arduino is able to turn it on and off for different durations of time depending on what the sensor reads. And the sensor's connected to this little board here, which just turns it into an analog or digital output, which goes to the Arduino. The servo motor is connected directly to the Arduino via a little 3-pin connector I made on the breadboard there. This is another H-bridge motor controller. This one can handle higher supplies. It's a 12-volt one for these two 12-volt motors. And we've got these 4 wires here connected to the Raspberry Pi to turn it on and off and change its direction. This is a test for BluBot to check that it's watering the correct soil. So the one on the right is a dry set of compost, fresh out the bag, and the one on the left is some damp compost. So the idea is, hopefully the robot's going to check both of them and determine if they're wet or dry, and then it'll water the one that's dry. I've done it on a board, on a table, because I wanted to test that, first of all, I've got control over the moisture in the soil, because if I'd done it in the garden, it's been raining fairly recently and the soil's all damp anyway, so I wouldn't really get a clear boundary between what's wet and dry. Whereas with this, I've just taken this fresh out of a bag, so hopefully the one on the right's dry enough that it'll detect that. So I'm going to give it a go now. So I'm going to put it into the mode and it's going to start doing it. So here we go. So that one, it don't think is doing it. So now I've got the other one. Yep, so we've successfully watered that one. So I think that's a successful test. So, yep, that went well. So as you can see from that video, I've got a nice soily sensor and a nice wet piece of wood to clean up. But I think the test went well.
This is just a really rapid run through of the CAD and the programs that went into building this version of the robot. So this is the initial version. I'll put a photo in. That was 3D printed, but it didn't work particularly well. It didn't have much weight limit, and it wasn't very good at traversing soil. So I upgraded it to this track design with a screen, and it's much more interactive, much easier to use, and it's got a much larger power supply due to the solar panel. This is the Python script that runs on the Raspberry Pi. So that's there, and you can see here we've got the 4 pins that correspond to the 4 pins I showed you in the motor control bit of the video. We also have down here the C++ script, which runs on the Arduino Nano that I showed you on the bottom. So that just basically receives inputs via this Python script through the USB cable and responds accordingly. So in terms of what I've learned from this project, I've obviously fine-tuned my CAD skills. I mean, I've never designed quite a complex robot like that before in CAD, and massively improved my programming skills, in particular serial communication between Python and Arduino. It's a big area I've been learning about for this project. In terms of future things I'd like to do with it, I am going to, like I said, improve the QR code thing. So I'm going to work on getting the QR codes to read from a camera, identifying, markers for each plant, telling the system how much water it should be given. So the idea is the Raspberry Pi would read the QR code through a camera and send through the USB cable, the Arduino, the commands to determine how much water to give it based on the soil sensor. So I think that's pretty much all I've got time for. So thanks for watching, and hopefully see you guys again.